Good morning, everyone. Am I audible? Can someone acknowledge?
Yes, sir.
Yes,
Okay, thank you. So, good
Yes.
morning, one and all, to all the dignitaries and all the participants for our second day of Atal FDP on design thinking, practical perspective on decision making education. So, our first speaker for the day is Dr. Y.S. Rao, and let me take the privilege to introduce him. So Dr. Y.S. Rao is Vice Principal of SPIT. He has pursued his PhD from IIT Bombay. He has completed his Masters and Bachelors in Electronics Engineering. He has published many research papers pre and post his PhD. He was awarded with the Honorable Mention Award by IEEE Computer Society, Washington DC, USA, at the International Design Competition. He is active researcher and he is active in making the hardware boards on embedded system and IoT. So he will be joining us very soon. Meanwhile, he has shared one of his video, and I will be taking you through to that video. So I would like to welcome Dr. Vaisarao for his session, and I will just start a video in a minute.
Good morning, one and all. Welcome
Is it
to the
audible?
session Product Design
Yes, yes.
yes,
for
sir.
Mobile Lab.
Okay.
Today I will be introducing you the problem statement and our solution to the problem statement. Before I talk about more on the problem statement, let me introduce you some of the test and measuring devices which we generally use in the laboratories. The laboratories I'm talking about as an engineering perspective, not as an industry perspective. In engineering, particularly the circuit branches like electronics, telecommunication, instrumentation, or the core branches, electrical engineering, or the allied branches like computer and IT branches, where they will be using some of the test and measuring equipment for conducting some practicals, also some mini and major projects. The subjects are like, right from the first year engineering itself, they are supposed to do some hands-on sessions on basic electronics and electrical, digital electronics. Maybe in second year, including in computer IT, they're supposed to do some electronic devices and circuits. And electronics and telecommunication and electrical students perform some practicals related to analog circuits, network theory, linear integrated circuits, and so on. At the higher semesters, including computer IT, they have subjects related to embedded systems, that is called cyber physical systems, design with microcontrollers for various applications. And nowadays we have the subject called Internet of Things, which is an emerging field, which is going to replace our conventional traditional communication systems with the Internet of devices, right? Internet of things. Things means devices. Now imagine five to somewhere between 5 to 7 subjects, almost all these branches. Even these things are there, even mechanical engineering, they have a lot of automation, robotics applications. So I would say almost there is no field or branch left where automation is not done, right? So keeping in mind the trends, the futuristic products, software in hardware and smart devices are almost everywhere. So now that's the reason why these branches are upgrading the subjects or are adding these electives in terms of software hardware partition even in these core subjects. Like we have seen how the 3D printers have replaced these traditional electromechanical things. So it's the need of the hour. All right. So the equipment what we generally use in the laboratories are, to begin with, let's say a oscilloscope. Earlier we used to have a cathode ray tube, CRT, CRO, cathode ray oscilloscope. Almost we have replaced with the digital storage oscilloscope, DSO. So what for we use this equipment is, as you can see, instead of using cathode ray tube, now we are using this LCD. There are, you can see, inputs, what we call as a channels. So if you want to display any waveform, right, whatever is the nature of the signal you would like to see, that signal we give it as an input to these channels. Right now, this oscilloscope is a 2 inputs oscilloscope. So whatever is the signal you would like to see, it could be a mechanical like vibration signal, or it could be a biomedical instrumentation like ECG, EMG, and so on. Or it could be electrical like voltages, currents, or power signals you would like to see. Or maybe in telecommunication, you would like to see modulation, amplitude modulation, frequency modulation. Any type of electrical signals which is coming from either from the circuits or coming from the sensors, you would like to see them. So that's the reason why we use this oscilloscope called digital storage oscilloscope. We are saying digital storage oscilloscope is because it has the ability to store the signal. As you can also see, externally also you can save it, right? There is a pen drive where you can insert it and you can transfer the signal. So what you can see, the options is there are some potentiometers are there. By adjusting these knobs, you can adjust the amplitude of the signal, whatever you are displaying. That is x-axis and y-axis. The way you zoom it on your mobile phone, your picture, right, by touching the screen. Similarly, by rotating these knobs, this X and Y scale factor, you can increase or decrease, either multiplication or division, that you can do it. So that is a scaling you have, what is called time scale and the amplitude scale. So there are two ways of displaying the signal. One is what we called as a time domain signal. Second is called frequency domain signal. In the sense, this x-axis you want in time or you want frequency, right? So there are two possibilities. As you can see, there is a button called FFT, right? That means if you want to display the signal in frequency domain, that means x-axis is representing frequency. Then you can go to this option called FFT. Otherwise, traditionally, we want to display x-axis as a time, y-axis as an amplitude. So that's where these two knobs, this and this. So this is for your scaling of this time, and this is the scaling of the amplitude. You can do it. So since two channels are there, so both the channels individually you can control the amplitude of the signals. There is a trigger signal is there, where if you want to display the waveform, a stable waveform on screen, so that signal should be triggered. That means the sweep generator should be triggered with reference to what? This X or Y, so that has to be decided. What is that magnitude of the input that you have to select it from the trigger signal. Similarly, you have other options. That is, as I told you, there is a inbuilt facility for storing the waveform and analyzing the waveform, measuring the signal, and so on. So all those things are available here. So basically, a CROs you get based on this, as you can see, the bandwidth, right? For example, this is 100 megahertz. You get 50 megahertz, 20 megahertz. Even up to you get even 500 megahertz is available, which is expensive things. Similarly, the sampling rate, how many samples you would like, it can take per cycle is also it's mentioned here. And of course, this is a colored, that means if it, when it is displaying the waveforms, that is the channel 1 and channel 2, it will display in two different colors. So that means your screen is in a color form. All right, so this is the most common measuring equipment which is used in the laboratories for almost all the subjects, including the projects. Whenever you want to see any waveform, the nature of the waveform, irrespective of it is a linear, non-linear, repetitive, non-repetitive, whatever, right? We would like to see that. That for that purpose, we use this digital storage oscilloscope. But there is a problem here. The problem is how many waveforms at a time you can display is only 2. Right? There are CROs which are available 4 channels, but it's very expensive. Even this one will cost you not less than 60,000 rupees. And a little bit bulky also, dimensions wise, weight wise. This is one problem where generally we notice that providing every student one CRO is an expensive option. And the second is it is not easily carryable because it has size and weight. Okay. And the second problem I said, it is about the number of waveforms at a time you can display on the screen is only 2. Okay, that means if at all, if you want to compare, you can compare only 2 signals simultaneously. Okay, that's the one equipment. Second equipment is, as you can see, what is called as a function generator. Okay, function generator is the one which will generate the waveform, right? This is the output. Whereas in a CRO, it is the input, right? You would like to monitor the signal, whereas in function generator, it generates the signal. Now, function generator, where as the name says, function means different types of functions. Nature of the output is available here. What type of output signal you want to generate, right? That you can choose with the help of these buttons. Would you like to generate sine wave? Would you like to generate square wave? Would you like to generate triangular waveform? So function generators are available. These 3 types of waveforms it can generate, right? So when you want to generate the waveform, what are the options you are looking for? A, type of waveform. B, amplitude of the waveform. C, frequency of the waveform. So whenever you want to generate any waveform, you would like to have the options on the function generator. You would like to change the amplitude, you would like to change the frequency of those signals which are generated, as well as the function. Then the other issues are, whenever you are generating a waveform, the polarity of the signal, right? Positive peak, negative peak, or would you like to shift it? Would you like to add some DC component in it? That is called offset value. So you would like to add some offset value to the incoming signal, so that you do not want to have the signal of negative polarity. Everything you want to uplift on the above the 0 axis. So those are the options you would like to have on a function generator. The other thing is I thought of saying something. Yeah, frequency range. What is the maximum frequency a function generator can generate? Say, for example, in this case, it says that 3 megahertz. So 3 megahertz is the maximum frequency it can generate. So anywhere between 0 hertz to 3 megahertz, you would like to have a variable frequency. All right. So this is again a most commonly used equipment in the laboratories, because you would like to have a reference, right? A reference waveform to be generated, so that whenever you design any circuit, you require input to the circuit, right? Some waveform you would like to give it, or some pulses you would like to give it, like for example, a counter you have in digital electronics, you would like to generate some pulses and with a variable frequency. So this is that's why it's called as a test equipment, because it will generate the reference signals. But again, you have seen it's a little bit bulky, heavy in size, and the waveforms it generates is fixed, right? The nature of the waveforms, that is triangular waveform, sinusoidal waveform, or these digital waveform, right? Pulses. Cost wise, it's not less than 12 to 15,000 rupees, right? So this is another, if not very expensive, but expensive and a little bit heavyweight. So this is the second most commonly used equipment in almost every subject. The third is, of course, uh, any electronic circuit or any embedded systems, any cyber physical system work with power. If you don't give the power, none of them will work. Naturally, the system will start functioning only if the power is given. So how will you give the power, right? You have not designed any, any system for the power. We assume that power is there, right? We are supposed to give the power. But the power is not our conventional power, what we are getting, that is 230 volts AC. No. Almost all these components, electronic components, they are working on an amplitude anywhere between 0 to 5 volts, or at the most 12 volts or 15 volts DC. So you want to give a regulated, right, constant DC without having any pollution in that, no ripple on the signal, a pure DC as a reference. Then only you can, whatever the circuit you have designed, you have mounted, you would like to verify. So as you can see, a heavy weight, I cannot lift it I mean, easily, not less than 10 kg weight. What you will have is, as you can see, these knobs where you have 5 volts, 12 volts, 15 volts, at the most 30 volts, where you can output, you can adjust with the help of these knobs, potentiometers, a DC output you can change. So it will indicate, right, what is the voltage and how much current you are drawing, right? So being a regulated power supply, whatever is the voltage you set, it will work. But as you can see, it is heavy weight. You can see, I mean, it's very heavy. Heavy weight because inside it has a transformers, step down transformers. They don't use the SMPS, what we generally use in computers or the electronic equipment, because the output voltage, what we want is from the linear output, not switching mode output. Because SMPS, switching mode output, will have some ripple in it. So that cannot be a reference for our most of the electronic circuit. All right. So a power supply anywhere between 3.3 volts, 5 volts, plus 12, minus 12, plus 15, minus 15 is the requirement for almost all electronic circuits. So that is the third, which will cost you somewhere around 10,000 to 30,000. It depends on the quality of the output and of course the power ratings. That's the third one. Fourth, I would say, I mean, not always, but what is called as a arbitrary function generator. Okay. So what do you mean by arbitrary function generator? A conventional function generator will generate only a predefined waveforms, right? Only sine, triangular waveform, and this square wave output. But a arbitrary function, arbitrary means any waveform, a user defined waveform, whatever you would like to generate, it will generate. For example, ECG you want to generate, vibration you want to generate, or some earth signals you want to generate, earthquake signals, or whatever, any type of waveform, linear, non-linear, anything you want to generate, it can generate. How it will generate? Through software, right? You are supposed to connect this to your computer by using this USB interface, and then design your waveform on your computer screen and download it. Once you transfer it, it will display it here as well as the signal is available here. It is mainly used for in telecommunication as well as in these biomedical applications, where the signals which we are unable to generate from function generator, those signals could be generated by using these arbitrary function generators. So that whatever is, for example, I have designed for some biomedical ECG analyzer, but I require a ECG signal. Every time I cannot connect the probes to a patient, right? So 24/7, I want some signals, real-time signals. So those signals we can obtain from these arbitrary function generators, right? So the nature of the signal, the repetitiveness, the storage part, everything is possible in these user-defined function generators. Again, it is a very, very expensive, not less than 70 to 80,000 rupees. And you have seen bulky also. All right, so these are the generally used equipment. Otherwise, we know multimeter is most common thing. It's not expensive. Nowadays, every student is having a, in hardly some 400 rupees, you will get at least a reasonably good quality multimeter. So I don't say it's a major challenge. But otherwise, also in every institute is giving students multimeters and breadboards. Okay. So in short, in this pandemic situation, when students are not coming to the colleges, or even after this situation also, if students wants to perform any practicals or wants to build any products or projects, then the challenge is such type of equipment, right? The bulky equipment, costly equipment, they are not available to the users. That's the problem. So that means, as you can see, this itself is not less than 2 lakhs, this equipment. And then even in the engineering college, no, it depends on the type of college. Generally, no, these are all shared facility where a group of students will be sharing these equipment. And I'm doubtful how many colleges are having arbitrary function generator or such type of equipment, or these logic analyzers, those where you can display the multi-channel simultaneously at a time. So these are some challenges currently. Almost every student is facing availability of the laboratory. Though online, remotely they are studying, but the skill development is a major challenge. And if you look at the volume, right, if you look at the size, I'm sure every university is having 50 to 60 engineering colleges. And these branches are most common, these circuit branches are most common in every institute. And in a state, there are 300 to 400 engineering colleges. And at a country level, it could be around 10,000 engineering colleges, and maybe half equally polytechnic or diploma colleges are there. So what are the total number of students? Not less than 10 lakhs of students. Because irrespective of branch of engineering, irrespective, including textile or metallurgy, first year is a common syllabus. That means every student must know about this equipment. Even in the industry also, as I mentioned, almost every industry there is automation. Every field there is automation. That means every branch, right, wherever they are working, they are supposed to deal with this kind of equipment. So if the students are not having confidence in using this equipment or analyzing these signals, and if you are only have some theoretical knowledge, not the practical knowledge, that is the really big challenge, that why our students are not employable, or the industry is not doing good, the core industry is not doing good, or there's no competitiveness worldwide because of lack of these skills. So these are some I would say the gaps we realized at our SPIT Product Development Center. With this, we thought, our management thought that can we provide such kind of facility to every student? First at our SPIT level, then eventually let's see at how it goes to state or national level. So how to bring the cost of this equipment, right, this entire setup, to few thousand rupees, affordable thing. And the lab means not only this equipment, right, you are supposed to provide some components, right, which are used for conducting those experiments, right. What are the subjects? As I said, BW, EDC, LIC, embedded systems or Internet of Things, and so on. So can we provide, right, all those things what generally are supposed to learn in these 4 semesters, right, or maybe in electronics it may be 8 semesters, whatever. Can we provide this, what is called a mobile lab? There is a first problem, or I would say the idea. for this session, what I'm talking about is the product design. Second level is that now, since these things are remotely happening, can a faculty can remotely monitor what a student is doing, right? Because I mean, since it is academics, it's not only a project, it's also sometimes is a part of academics. A faculty is supposed to go through the experiment, whether he is genuinely doing or not, and what are the results he has got, and is supposed to be get it graded in real time. So can we integrate this internet, right? Internet of things, because here things means our lab. This lab is a things. Now this should we put it on the internet of things. Then this, if you integrate as a part of the computer networks, then remotely from anywhere in the world, this laboratory a student is handling can be accessed from anywhere in the world. A faculty can handle. So where this computer networks or internet comes into picture, and then capturing the data and analyzing the data and evaluating the data should happen in real time. So can we integrate some this what is called this learning, right? Teaching and learning methodologies into our lab, right? I'm talking about the ICT tools. So if we can integrate, then what is the volume? The volume is every branch has 70 students, and every student is having 4 to 5 subjects, and there are 70 institutes in a university, and then 300 institutes in a college, in a state, and in a country there are not less than 15,000 including diploma colleges. So 10 lakh students data, 5 subjects has to be in real time. I mean, I'm talking about the upper side. Can we capture it? Can we analyze it? And can we provide some solutions for that, right? So this is in short, I would say, the concept here or the idea here, that how can we help to begin with our students in skill development, our institute in cost cutting and improving the skill set, and in short, the country, how we are, the society, how we can help in terms of availability of the resources indigenously designed. As a nation, I mean, see, I'm sure not even a single company is there in India who is manufacturing these things. Even if they are manufacturing, they are importing the parts and assembly, or they are just only changing the labels on the parts. But otherwise, except the power supply part, most of the things are imported. And now, so in short, we are going to save the imports. That's what the economics part of this idea. All right. So this is my our proposal. Now, in the second session, we will see how this idea can be converted into the specifications, right? I would say the design part. And once the design is done, then we will discuss about the block diagram design is done. Then we will discuss about the circuit design. Once the circuit is designed, then we will talk about the prototyping. Once the prototyping is done, then we will discuss about the final deliverable things. So these are the various stages of any product, right? So who is the customer here? The customer here is our student. Okay. So that means now we need to understand as a student's perspective, not as a designer's perspective or a manufacturer's perspective. The user is he or she could be a first year engineering student. And a first year means a 12th passed out student. A 12th passed out student doesn't have the knowledge of any of the software, hardware tools. That is a challenge, right? And a faculty is not in front of them. That is the second challenge. They are remotely working. We are not talking about final year students. We are talking about this has to be introduced at the first year, first semester itself. So those are the design challenges. So we have to discuss about those issues while doing the designing. All right, so this is my first part. In the second part, we will talk about the specifications part of it. Thank you.
Amol sir?
Yes, I'm playing the second
Yeah.
video.
Welcome to the second session on product design of the mobile lab. In the first session, we have discussed about the requirement or the need. As we all know, need is the mother of invention. So the need is about the
Yes, audible.
remotely performing the practicals or doing some projects related to electronics and telecommunication, or cyber physical systems, Internet of Things. So in that case, what are the facilities are required? How to have a mobile lab concept? So that's the requirement. That's what we have discussed in the first session. So in this session, we will discuss about that need. We need to list out the specifications. What are the specifications? We need to convert into specifications part. All right. All right. So the it's not only converting the idea into specifications. We also need to look at the who are there already in the market. So that's why we always say the gaps identification, and accordingly we have to make a product. Please note, this is not any research or project. It is a product. We have to compete in the market. There is a commercialization part of it, right? So we have to always look at in that aspect, the customer's requirement. Customer's requirement means not only the specifications, they also look at the cost factor, features, right? And the user friendliness and so on. Okay, so since we are talking about reconfigurability, right, reusability in multiple aspects as far as this platform is concerned, what are the things we would like to cover is we want to eliminate the DSO, we want to eliminate the power supply, we want to eliminate the function generator, and also we would like to have an arbitrary function generator as a part of the system. And what are the subjects we would like to cover is basic electronics, digital electronics, electronic devices and circuits, network theory, linear integrated circuits, mini and major projects. So the system should have a multi-channel data acquisition, and the power supply should be at least plus 15, minus 15, plus 5, 3.3 volts. It should not only have a function generator, but it is a digitally synthesizable function generator. And of course, user interface, HMI part, as well as Wi-Fi part, because we want to put it on the internet. It's a cloud computation and remotely accessing for evaluation purpose. So when you want to perform these such kind of practicals and want to make use of components of this type, we have to look at what is the commonality between these subjects as well as within the subject. Since every subject has at least 10 to 15 practicals need to be performed, what is the commonality between the these components or the circuits. So that is what we have to work it out before actually we make the system. Okay, so let me read out what so far I have spoken as an abstract of this proposed system. The analog and digital electronics laboratory requires many large test and measuring equipment for a single circuit to verify. This is a very expensive option if an individual student wants to experiment at his residence. Also, the other problem is space requirement. The mobile electronics lab makes it easy to design the experiment without any soldering. Students can explore a wide variety of all right, so all connections and controls are marked and conveniently located on the circuit diagram so that one can easily identify. It is very useful in analog and digital electronics laboratories for performing experiments remotely. It is also useful to build and test mini projects related to analog and digital electronics or while doing the coursework. The Piggy Backboard is optionally mounted on a baseboard that is specially designed for a specific subject. So this entire system is divided into two parts. One is called baseboard, the other called is Piggy Backboard. The Piggy Back is an optional one which is mounted on the baseboard. So Piggy Backboard is designed as per the subject. Baseboard is a commonality for all the subjects. All right. So the baseboard is a high performance dual core RISC-based system or a data acquisition system. And this conventional lab setup requires a power supply, function generator, DSO, I told you already, cables, connectors, and components. So naturally, these things are as a part of the system. So the functions of power supply, function generator, and DSO are replaced by baseboard, right? So whatever we said so far about these three things are, those features are there on the baseboard. The system has a built-in power supply, also works on your USB. Through USB also you can give the power. It has inbuilt clock, LED, 7-segment displays, graphics LCD, whatever you want to interface, it is possible, including the multiple sockets. Since it has a multiple communication, like Wi-Fi, Bluetooth, USB is all possible. It can act as an alternative for this, including arbitrary function generator, and you can interface to PC as well as mobile phone. Also said remotely it can monitor through the IoT devices. So this is the need of building the a mobile electronics lab. And in short, I was telling this is our proposal that as I mentioned, at least you should have a high-end computational unit on the baseboard which can take care of these three test and measuring equipment. Okay, so what is the policy here? It is not an experimental board for 1 or 2 students or couple of students. The policy here is that this system every student should have, right? Wherever they are, whatever, whether in a hostel or in their house or even in the regular laboratory, whenever they want to do any experiment for electronic components, a student should have this laboratory at their disposal, right? Some of them may be first year students, some of them are second year, some of could be a final year students. So looking at the pandemic situation and the importance of activity-based learning, mobile lab we would like to issue to every single student. But as I said, not only in this situation, even after that. The Piggy Backboards have the features to cover the following subjects to perform the experiments remotely, like BW, LIC, EDC, digital, network theory, embedded systems, as well as IoT. So these are optional boards. Piggy is whenever you want to perform such type of experiments, then only we use it. So the Piggy Backboard, there is a BW network theory. A board is separately designed for first year students. Digital systems, there is no Piggy Backboard, that is already there on the baseboard for first year students. But however, this analog electronics or EDC, right? Like those what's called linear integrated circuits. For second year students, there is another Piggy Backboard. Then communication and measurement, right, which is common to all, that could be part of the system. And then finally, embedded and Internet of Things, which generally happens at higher semester levels. Since the commonality as far as the baseboard is concerned is a DSO, function generator, power supply, and some few sockets, some few LEDs, or no, those sort of things are the commonality. But however, the subjects, there is no commonality, right? BEE is altogether about basic electronics. Digital electronics has a altogether different requirement. Linear integrated circuits has a different requirement. Communication IoT has a different requirement. So that is why we have separately designed a Piggy Backboards where at least 10 to 12 experiments, we brought some commonality between the experiments as far as that subject is concerned, and the Piggy Backboard is designed for that, right? So now you have a, like, no, in computer, you have a motherboard and daughter board, and the daughter boards are the optional boards. It's a choice to the user. Similarly, we have designed this Piggy Backboard, which is a daughter board, which is a choice to the student. So as and when a student is studying a specific subject, then that particular board will be attached to the baseboard. However, baseboard has already has this function generator or data acquisition system, power supply, and a few interfaces like switches, LEDs, LCD, 7-segment display, and so on. Okay, so before we finalize, we freeze the specifications, we need to also study about are there any products already existing in the market. Of course, there is no competition. I mean, these are multinational companies already there last 15, 20 years. National Instruments, NI, they have their own NI Elvis platform, which is having a compatibility to LabVIEW, which is a software. It has many features, undoubtedly. It's a worldwide used in the industry also. But undoubtedly, this is a commercial and very, very expensive solution where I am doubtful even for an institute also to have such kind of a facility. Spending lakhs of rupees for one facility is itself is a challenge. So though it has ability to perform some practicals for different subjects, and it has a user interface, but this solution is not suitable as a mobile lab to an individual student, right? So we cannot make it as a mass and as well as the open source by using this platform. So those are, I would say, as a reference, it's a good idea. But as a comparison point, it is like, you know, having a huge multi-ton air conditioner tower versus I require a small 1-ton air conditioner. So the difference is of that nature. So we doesn't require such a high-end system. I mean, that's the problem here. Second is Texas Instrument as a university program. I mean, in India, they have started what is called SLK Pro, but they are not covered for all the subjects. They have started with few subjects. For example, linear integrated circuits, they have started. Now, it's a nice product. It's a, of course, low-cost product. Their manuals are good, undoubtedly. A lot of even some IIT professors also contributed for this product. But then this is specifically designed for Texas Instruments components. They have not taken care of all other components, only specific components of Texas Instrument. But another issue with this product is while using this product, you still require a laboratory equipment like CRO, function generator, power supply. Those things are still required. So it is just a experimental board. However, along with you have to have those test and measuring equipment. So that's another challenge. So now these are the good references for us One is a standalone system, but still require this test and measuring equipment. Second is specially designed for a specific subject, still require a lot of test and measuring equipment. First one is pretty expensive, second one is a low cost, and the good manuals are there. But then it's for a very specific topic, and still you require a lot of test and measuring equipment, if at all, if you want to use this board. Okay, so this is our study. The gaps, both the products require test and measuring equipment. Cost is a really matter of concern, because even institutes are not, majority of the institutes are unable to offer such kind of solutions, because they are commercial, right? They are not freewares. Okay, so that's the I would say though it's a idea is a need of the hour, but then we also need to look at the market point of view, that who are your competitors, what are their features, and then the possibility of mass production. If you look at, then we have a better chance, because those are the gaps. All right, so then what is our solution? Okay, so our solution is as follows. When we convert this requirement into design into solution, first thing is we need to identify the components, because it is a trade-off. It's a system design, that is co-design. You need to look at various aspects of the design: cost, size, power consumption, features, right? Flexibility. These are all correlated. We all know if you try to improve one aspect, right, one parameter, some other parameter may suffer. For example, if you want to reduce the cost, somewhere you have to compromise in terms of some features. You won't get all the features. For example, why people go for these smartphones, right, which are costing 30,000-40,000 rupees, even a lakh of rupees. The smartphone is available from 3,500 rupees, right? Such a low cost smartphones are also there. Same operating system is there. Same touch screen is there. All the features are there. But then why there's a huge business for those luxurious phones? Personally, I don't prefer, but yes, we know it's a billion-dollar industry. Similarly, the luxurious cars. You will get a air-conditioned four-wheeler, reasonably good speed, which is good enough for city roads, around 3 lakhs. But then why people are spending 15 lakhs, 30 lakhs, 50 lakhs, 1 crore, 2 crores, 5 crores? So, so somewhere something has to be compromised, looking at the cost, features, size, efficiency, and so on. So these are all the design issues. We all know particularly in automobile sector, the comparison between German made, US made, and Japanese made. Every company has their own policies, so they have their own market share. They have their own customers, right? Since in our case, we are looking for the larger scale, larger picture, and cost is an issue. But at the same time, size, power consumption, and the flexibility, reusability is the really worrisome for us. So somewhere we have to look at all these design constraints. We have to look at those constraints, accordingly design our product. As I told you, if you go for a power supply, which is a SMPS based power supply, you can save a lot of cost, but then the output won't be a ripple free output, definitely there will be a ripple. And the safety point also, it is not advisable, because directly you are converting the 230 volts into DC without any isolation. So we preferred a regulated, linear regulated power supply by using a step down transformer. And then we proposed the components like LM317 for variable DC, and 7815 for plus 15 volts, 7915 for minus 15 volts, and 7805 plus for 5 volts, and 1117 LM 3.3 is for to generate 3.3 volts DC. All these regulators will give you a constant voltage, and the current carrying capacity, that's a load, is 1 ampere. So this entire board, all the experiments, when you are interfacing any, even the devices like DC motors or stepper motors, you have to keep it in mind. These are the limitations. So any system, the load in any system, in any electronic system, load means current. So you should never ever exceed the specified amount of current. Otherwise, you are going to damage not only the drivers, also the power supply. So you must always work in a given conditions, right? You are working in a constrained environment. Otherwise, in a laboratory, you may get 2 amperes, 3 amperes power supply. You will also get power supplies which is having a variable voltage up to 30 volts and so on. But we have to limit ourselves to these 4 sources, that is variable DC and plus 15, minus 15, plus 5 and 3.3 volts with 1 ampere current, because almost all the subjects and practicals demand this kind of an environment. All right, so this is our proposal for a power supply design. For those specifications, we have chosen these components. Second is the heart of the system, that is your data acquisition. Since we do not want to use a conventional digital storage oscilloscope, and even the logic analyzer is also very expensive, and generally it won't be there in the laboratories, right? It's very rarely used solution. So we want to have that feature in our system at a time, right? Multiple channels, not only 2, no, even 8 channels. We should be able to see 8, 10, 12, whatever possible, right? As a digital monitor. Similarly, analog also, why 2? No, we can also have a multiple analog channels, up to 8 analog channels is our target. So our data acquisition is a multi-channel analog as well as a digital, and also has the ability for the D to A converters, right? Digital to analog converters up to 2 channels. That means it's like an arbitrary function generator. Whatever you design through software, that waveform should be available at the output, right? So that's the arbitrary part. And then when I'm saying multiple analog inputs, right, then you also should have a analog to digital converter, which is having multiple channels. So at least we targeted, as you can see, these 12-bit 18 channel and DAC 2 DACs of 8-bit. That is the resolution part. And then the communication, right? Since we would like to communicate to computer by using USB or UART or no Wi-Fi, Bluetooth. So we would like to have multiple types of communication systems. So it's a choice. How do you want to communicate, through mobile phone or to a computer or through a laptop? So what is that you want to connect it should be a choice. This entire board should work on low voltage. So when we are targeting for 3.3 volts operated system, and compiler, see, finally you need to write a program. The compiler should be open source. That is our target, because no, we do not want to use any pirated version, or no, we do not want to break any law. So we prefer a compiler which is a freeware. So yeah, so we have to look out to the controller which is supported by a freeware unlimited licensed versions no limitations for the students. So that's another way of identifying a computational device or the architecture of the CPU. And the operating speed, we preferred at least in 100, above 100 megahertz should be the computational speed, and preferably at least a 32-bit CPU core, so that you can have a high-end mathematical operations can be implemented. And reasonably good memory, like static RAM is very, very rare, having few kilobytes. So, but still we are able to get up to 512 kilobytes. And the flash, where our program memory, right, entire our operating system, mini scheduler is stored, is up to 2 MB we can target. So this is in short identification of a computational unit in order to implement your logic analyzer, CRO, function generator, data logger, wireless communication, and so on. So the most crucial part of your system design is how will you choose or how will you satisfy these requirements by identifying those components. Okay. Then, so that is the logic analyzer and DSO part. Then about the function generator. Function generator ICs are available, right? I mean, they are there last 30, 40 years. But then, since we are implementing a digital, completely digital, means through software we want to implement these programmable function generator. So we were looking for a direct synthesis function generator, DDS. So DDS means it's a peripheral which is interfaced to microcontroller, and you write a couple of control words, then it will start generating the waveforms as per your desired frequency. So no hardwired function generators, because we want this to be a programmable version. Through software we want to control what is the nature of the waveform we want to generate, what is the amplitude of the signal, what is the frequency of the signal, should be programmable, and being digital synthesizable, it has its own resolution, right? That depends on the number of bits it is representing. Good. So that is another way of satisfying. As you can see, I mean, the operating speed is up to 25 megahertz is what we have identified, a DDS function generator. Okay. So these are the specifications. The output frequency could be up to 12.5 megahertz. Is reasonably good as compared to traditional function generators, which are having only 3 megahertz analog function generators. And it has the ability for offset adjustment, amplitude adjustment. 28-bit is the resolution. So that is the most, I would say, the best way of getting the resolution up to 28-bit, 2 raised to 28. And the programmable part is sinusoidal, triangular waveform, and square wave. Like a traditional function generator, it can generate those things. It can operate anywhere between 2.3 volts to 5.5 volts. So since we are operating on 3.3 volts, so it is good. How will you interface to CPU? So it has a SPI interface, serial peripheral interface, a 3-wire communication. So the SPI port of your CPU can dedicate for this function generator. And it satisfies your industry standards automotive applications and operates from minus 40 degrees to 105 degrees centigrade. So it's a pretty good. All right. So this satisfies our third requirement. We have completed and identified the power supply. We have identified the computational unit and communication system. And we have identified the function generator, which can replace our traditional function generator by using DDS function generator, which is a software programmable. All right. So that completes the major components of the system, or I would say heart of the system, where we need to start the design. So far, I said only identification of the components. Now this thing has to be converted, right? By using of those components, you need to convert into design. Here you also have major challenges. What are the challenges? The challenges are, what are your subjects? and those subjects, what are the types of experiments, and those experiments, what are the resources they are demanding, right? What are the nature of the signals? What is the frequency, right? What is their amplitude? You have to look at all these aspects. Accordingly, design a signal conditioning circuit. Okay. So, because see, I mean, what is signal conditioning? Signal conditioning means the signals are not directly compatible between the circuits, right? For example, if you want to perform an amplifier, right? The amplifier output could be a plus 15 to minus 15, right? The amplitude of the signal is a bipolar, and the magnitude could be plus 15 or minus 15. However, if you want to give that signal to your CPU or to analog to digital converter, it may accept between 0 to 3.3 volts. It's not compatible. So that's the problem. That is a really, I would say, a challenge, that how will you make your design so that it is compatible between the systems, between the devices. Anyhow, it's a proprietary part of it, how we have designed, how we have implemented that system. But I will describe you in brief with the help of a block diagram, if not a complete circuit diagram, because once this thing is probably patented, then I would be in a position to bring it to the public domain. So till then, let me explain you with the help of a block diagram, what is that you need to take care so that this entire system is compatible and will satisfy your requirements of multiple subjects and the multiple experiments. Okay, so let me represent our design by block diagram, if not circuit diagram. Maybe at later stage I will disclose you, explain you what is the circuit diagram part of it, or also the PCB design part of it. Once this copyright thing is done, then I will conduct that session. So this system has two parts, what is called baseboard and the Piggy Backboard. As you can see, the left side and right side, you need to provide some connectors where the Piggy Backboard is attached or sitting on the baseboard. Otherwise, the baseboard consists of what you can see here is about a risk controller, which has, as I already explained you, about a 32-bit core with has whatever is the listed peripherals like 8-channel, 18-channel ADC, 2 channels a DAC, PWM, peripherals, communication peripherals, and the GPIOs, memory, types of memory, and communication like Wi-Fi, Bluetooth. So we like to have these many features as a part of the computational unit. Then about your the inputs. Since the inputs are coming from the analog as well as the digital circuits, the signals, right, the entire board, the signals coming from various experimental boards or could be 3.3 volts, 5 volts, or between plus 15 to minus 15 volts. So that is the, your problem. The problem is the voltage could be anywhere from 3.3 to 15 volts or minus 15 volts. So the most challenging part here is the signal conditioning. You should make sure that at any point of time, the analog to digital conversion, right, which is happening inside the microcontroller, or which is one of the peripheral of the microcontroller, accepts only 0 to 3.3 volts. So this is the most crucial part of your design, that from anywhere, whichever is the experiment you are doing, that the signal should be brought it to the acceptable voltage level, that is 0 to 3.3 volts. However, while performing the practical, you may be working on plus 15, minus 15, plus 5 volts, whatever. But while measuring, right, while converting analog to digital form, it should be 0 to 3.3 volts.
So that is what your, choice of choosing the power supply. That's what I said, multiplexing. Actually, it's not a multiplexer, but it's a choice, choosing any of those operating voltages. And then once again, the challenge is bringing to the acceptable voltages, that is no negative polarity. Everything should be shifted to the positive side. That too up to 3.3 volts, because most of the microcontrollers have inbuilt ADCs where the operating voltage is 0 to 3.3 volts. So irrespective of the subjects, whether it is a BEE, network, digital electronics, right, these electronic devices and circuits or linear integrated circuits, whatever may be, right, your op amps, your transistors may be operating on 15 volts or minus 15 volts. But you need to finally, when you give it to ADC, it should be 0 to 3.3 volts. So that is called signal conditioning, where you have to have, and that too multiple channels, because as I said, it is 8 analog inputs we would like to have. Also GPIO, like for example, it could be your digital circuit, and it could be another 8 channels. So at least 16 channels of ADC analog channels, and is already there. No, we have a 18 channel ADC. So it will suffice our requirement that at least 8 analog channels and 8 digital channels could be interfaced, because otherwise also GPIO is 32 channels. But it's okay, we can have 16 channels of digital and 8 channels of analog. We can fulfill with the help of this signal conditioning circuit. All right, so that's the major challenge, that since we have multiple subjects, multiple experiments, but the voltages are of different nature, and we need to bring it to the acceptable form along with the protection. Because at any point of time the voltage should not exceed more than 3.3 volts. So you should have a protection on board, so that all the signals they should never ever cross 3.3 volts. There is a clipping, right? So that you have to take care, right? And then you can give it to the your CPU. And the display also, if not the like multimeter, but at least some values, right? Some text or numbers, numerical numbers or timers, timing values, you should be able to display it on some LCD, right? Graphics LCD is once again a pretty expensive one. It will cost you slightly higher, but we thought that let us provide an option of choosing the LCD on board, whether this graphics LCD or a text LCD. Right? To begin with, we are providing a text LCD, but it also, the same port also has the ability to interface a graphics LCD, so that if at all, if you want to plot the waveforms, you can plot the waveforms on the graphics LCD. Or you can also interface a touch LCD. These are all optional things where if any student would like to add his or her own some contributions, it's most welcome by interfacing such type of LCDs. Then about this function generator. This function generator is a, as I said, direct digital synthesis function generator, and it is interfaced to microcontroller by using a SPI port, serial peripheral interface, and by it's a 3-wire system. And but then the story is not over here. The function generator can generate only a few volts, right? Maybe a few millivolts, less than a volt output. That is not good enough to drive your most of your op amps or transistors, a subject like EDC, right? So you need to have a amplification as well as offset value addition, because function generator has this ability, right? A function generator where you can change the not only the function, right, nature of the waveform, but also amplitude as well as the DC value. You should be able to change it. So that is why it's another issue or challenge, that output of the DDS, where you should design your own signal conditioning so that it is uplifted up to plus 15 or minus 15 or a DC value. You should be able to add it, right? That's another requirement you need to fulfill as a part of the baseboard. Then about the arbitrary function generator. since you have a digital to analog converter and the DAC can generate various types of waveforms as far as the based on users requirement, but output would be at the most 0 to 3.3 volts. So if at all you want to bring it to plus 15, minus 15, again that DAC output, you should have a signal conditioning circuit. So I hope now it is clear to you that the design here, I mean, apart from choosing the components, you need to fulfill the requirement of a traditional function generator or traditional oscilloscope. And on top of it, we also added some logic analyzer features into the system. So those things has to be fulfilled along with some protection, because if finally by mistake also if a student does some some wrong connections, a severe damage should not happen, right? They should have a fearlessly should use the board, but some precautions we should provide so that much damage should not happen to those integrated circuits. So you should be very careful. I mean, otherwise also, a student, whenever they are using the board, strictly follow the operational manual and particularly make sure what is the operating voltages which you are using, and before you do any connections, make sure the input voltage should never ever exceed the specified voltages, because finally once damaged means damaged. It's not software that doing trial and error basis. In hardware there is only one chance, that's all. After that it's dead. There is no way you can recover it. Like it's like a dead person, that's all. There is no way coming back. You cannot again induce some life into the system. Nothing is done, because after all it's semiconductor devices. Once burnout means burnout, nothing else we can do that. Irrecoverable. So please take care while operating these things because they are very, very sensitive. Their percentage of tolerance is very, very less, hardly less than 5%. 5% of the total operating voltage. So we need to be very careful. That is why I said contribution means make them compatibility, right, of these signals. So how will you take care of the compatibility? How will you make the protection in the system? Along with, we also added, as I said, reconfigurability, reusability part of it, because we want to take care of multiple subjects and multiple experiments. And also we have added our own features. That's what I said, cloud-based solutions and mobile-based solutions also could be part of this thing, because that is the, the latest trends. As I already explained, we preferred a linear power supply since the protection is there, isolation is there, and the ripple part also can be taken care by linear power supply. So plus 15, minus 15, plus 5, 3.3 volts. And of course, variable DC is there on the board. And since almost any experiment demands a few LEDs and 7-segment displays, few switches, few buttons for pull up and pull down, along with a variable clock source, right? The clock, though you have a function generator, but still we preferred a standalone variable clock source by using 555 IC. So that these are some common resources. Let it be any subject or any experiment, or most of the digital electronics practicals can be tested and verified by using these components. So as you can see, there are 8 plus 8, almost 16 LEDs of common anode, 8 and common cathode 8, and 2 7-segment displays, and another 10 plus 10 pull up and pull down switches, which are good enough for almost all digital electronics practicals. And also it has a variable clock source. So without using function generator also, you can fulfill most of your counters or flip-flops experiments. And finally, there is a concept called add-on slots or daughter boards or Piggy Backboards, whatever you say, where you can see the sockets are provided, the female sockets, You can have the power supplies of 3.3, 5 volts plus 15 minus 15. And also you can have the signals for ADC, GPIOs, DACs, function generator, clock source. So all the resources, whatever is available on the baseboard, they also brought it on to these sockets or slots. Like in computer, you have the slots called ISA slots, PCA slots. Similarly, here we have provided these 40-pin slots so that you can interface these Piggy Backboards or experimental boards based on the subject. So this completes our second session on the product design of mobile lab, where we started with the idea, then we have identified some gaps, then we have proposed a design, and now we have identified the components. Now this part, whatever in principle we have agreed to freeze our specifications. As I said, somewhere you have to compromise. You cannot get everything. You have to have somewhere sacrifice you have to do. Then probably you will get a better things, right? So you have to be focused that what is that you want. So based on that, you have to freeze your design. Now let me introduce you the how to convert this design into a circuit form or a layout form. And then quickly I will explain you. Of course, as I said, we are still in the patent stage, still left. So meanwhile, I will also show you some experimental results or how the system looks like.
Rao sir?
Yes, sir.
Sir, we have completed the second video.
So how much time we have left?
Sujata madam?
I mean, this session will be
Sir,
over. I require another 25-30 minutes.
yes, sir. So we have that much time.
So, okay. So should I complete my this thing online?
Yes, sir.
Okay. So good morning, one and all. We started. I was recording this session yesterday. So that this is actually meant for students. So it's better to record it again and again. Students can see that. And we are looking for almost every single student. You all joined for this workshop, right? 5 days workshop on. We are all in teaching field. So I thought of taking a product which is actually used in almost right from first year to final year, most of the branches. So I thought of explaining with a case study. Yeah, any questions so far? Otherwise, I will take another half an hour.
Hello, sir.
Please go ahead.
Sir, what's the cost, sir? Like how much it is turning out?
This one is costing, yeah, with the GST, it will cost around 12,000.
Are you selling to other institutes also, sir?
Yeah, it's open for all.
12,000, sir?
Yeah.
Or only that baseboard or with some PG board?
No, I will show you. It's like this. Yeah, this entire system, the baseboard and the power supply, of course, all the, the connectors, cables, everything will cost you 12,000. But the Piggy Backboards, right, for specific subjects like LIC or BEE or EDC, that we have separately designed. I was explaining maybe in some other video. They are there on the YouTube.
I have uploaded on the YouTube. You can go through it. So these are the called Piggy Backboards. These are specially designed only for that particular subject, like LIC. This is the Piggy Backboard, and BW there is a Piggy Backboard. These boards, maybe every board may cost you additional somewhere between 2,000 to 3,000 rupees.
Okay, sir.
I mean, see, we are not making any profit. It is just, whatever is the cost, manufacturing cost, that's all we are charging, nothing else.
Okay, sir. Thank you, sir. Thank you, sir.
Yeah, good morning, sir.
Good morning, Nandini madam.
Sir, I would like to know, are there any RF boards in this, like these, like, piggy bank? Do you have any input into the RF boards?
Yeah, there is another board which I didn't discuss right now called Embedded Systems and IoT.
Okay.
Yeah, so there, we were talking about, if not completely RF, but like any wireless communication devices.
Transmitter receiver model.
Yeah, transmitter receivers like Bluetooth, Zigbee, or such type of embedded or IoT devices. There is another board. Since this is completely analog and digital electronics, the second board what we have designed is embedded and IoT. There, yes, definitely you can interface various types of transmitters and receivers, along with some peripherals like stepper motors, DC motors, sensors, all that.
Okay. Like, I would like to know any other company, like you said, National Instruments and other things like that. You have any idea about the RF boards who are into it?
Three company. Okay, RF boards. I think analog devices have their own product.
Okay.
Analog devices, but it's again their costing is around somewhere around 35,000 to 40,000 rupees. I think
because sir, the Zigbee model also is like it is around say 15K. How much is the Zigbee model?
No, madam. I am talking about the base board. The additional things, whatever you want to interface, so that whatever is the market cost here, or you can procure them and interface to this board.
Okay, sir.
I mean, it's okay. Anything is okay.
Okay, sir. Thank you. Thank you.
Mol, can you see my screen?
Yes, sir. Screen is visible.
Okay, so I will wait 2 more minutes, and then I will start this last session.
Sir, I think you can continue because we have next session lined up.
Oh, okay. So let me summarize what we are for today as far as my session is concerned. I'm not sure how many of you are having a background of circuits of electronics or telecommunication. But then finally, even if you are from a background of mechanical or civil or any branch, finally product is product, right? I mean, you need to understand what are the stages involved in the product. We start with idea, right? Some concept, but then finally it need to be launched, right? It need to be, I mean, you need to sell it, commercialization. We have a habit of doing projects, right? We are for several years we are doing projects, but then that is only third stage. It's not the final stage, right? Project is only a prototype or concept proving in the laboratory. But then unless you need to understand the customer and then customer satisfaction, environmental conditions, certifications, manual development, all those, I mean, taxation, copyrights. You need to take care of all these things. Then only, there is a revenue generation. Okay, so today we have started with what is called a platform for design of analog or digital electronics. Like Madam has talking about wireless communication devices, Internet of Things, and embedded systems. And the requirements also, I think we have elaborated in the video, that we want to get rid of the expensive things, because every house we want this, students should be able to use it. This is all about the skill development, which is very, very important. Government of India is also spending now in the budget around some 80,000 crores. They are funding for this manufacturing sector in electronics and telecommunication. Like Tata Industry is starting a fabrication plant and so on. So this is our turn now. It used to be, 70s was Japanese, then 80s was Koreans, and this 2000 is Chinese. Now, hopefully, now this coming 10 years, hopefully it is Indians in manufacturing sector, in electronics and telecommunication. Let's see. Okay, so product, I was telling, product is product. Finally, whatever may be the branch it may be. You have to start with the perception, but finally it should be a deliverable thing, right? Most management schools will show you this slide. That is, what is the customer's requirement, but how maybe the right from the sales executive to the production manager, designer, maybe there are in industry, there are various stages out there. How do they look at this product? This is a really matter of concern, because what customer wants. For example, if you see the last image where a customer wants a small jula, a small tire which is tied to a tree, that's what the customer wants. But then how it is projected at various stages, as you can see. These are all some sofa, or some some jula, or whatever. So we need to understand that whatever we are developing, is it satisfying the customer's requirement or not? Okay, so whenever you go for a new product, one has to question when, where, whom, how, right? There are some best practices before you actually start doing the things, right? Today we are having a discussion, a group of people who are discussing, or you also need to some industry, some visits to industry. You just see the existing products. Or in Mumbai, we have the advantage of this every year product exhibition, right? We have in Western Express Highway, we have all the entire multinational companies are coming here to display, demonstrate their products. So you have to look at all these aspects before you finalize your product and its specifications. But we know, particularly in electronics and telecommunication or in software, the product life cycle is very short, right? The peak period is very short. So if you take a longer time, longer duration for research and development, then you are dead. How BlackBerry is shut down, or Nokia for some period of time, though it was a leading company, but now it is struggling in the market. Like that, you can find like Kodak cameras. In the video I have shown several products, they are getting obsolete now, because they have a very short period of time. So quickly you have to develop, make a profit, and again you start redeveloping with new features. So profit is a very shorter period of time. You have to reinvest again on your product. Okay, so every product has its own characteristics. You have to carefully look at it. Product quality, product cost, development time. This is what I was telling you. Then development cost and development capability. you all know, when you want to say, anyhow you are making a prototype, but if you want to develop this as a product, then the capabilities, right? Do you have the ability to produce, for example, 100 boards per day? Or do you have the capacity to solder the SMD components? Or do you have the ability to go for the testing part, right? I mean, there are industrial testing and certification. So all those aspects, you have to carefully plan it first, isn't it? Because finally you are investing your energy, time, money, right? So plan it thoroughly. And there are challenges, right? I was telling you about the trade-off, right? Cost or the features, power consumption, weight, size. You have seen, some of the products, they talk about the lightweight, right? In mobile phone, it's very important how thin as possible, very, very lightweight. That is very, very important feature. And the power consumption, right? The mobile phone should consume very, very less power. But every time you are increasing the features, more computations, but you want to reduce the heat dissipation. It's a challenge, right? Then the dynamics, that is about the various technologies coming in the market. And I was telling about those very minute details, time, economics, right? And organizational realities. That is your, the industry and its licensing part, and your team, the workforce. So these are all, various stages. But fortunately, today we have this culture called startup companies culture. And this entire ecosystem is available in the startup companies, because those institutes, like for example, IIT Bombay in Mumbai, we have that advantage. SPIT also, we have a TBA, Technology Business Incubation Center. Like that, few colleges also started in Mumbai. So the advantage is that you may be having your own some concept and idea, but the prototyping and all these institutes are helping to convert into product. So even we are helping to convert into product. And we have another section called Business Incubation Center, where the seed funding up to 50 lakhs, the institutes are providing seed fund, right? You don't need to return that fund, right? It's for your product development. And then there are investors who are willing you to help in making the business model of it. So that is the beauty of this complete ecosystem. So nothing to worry. At least if you have an idea, there are now that support is there. This was the culture in US, but now slowly it is happening in India also. Okay, so due to lack of time, I'm not going minute details, but then I was telling you what are the various stages. Idea, then product screening, preliminary design, and final design. So these are the various steps of every product. Even if you want to showcase your work, right, you should prepare a proper roadmap, because otherwise why anybody will fund your idea, right? That's very important. And this is the last part of your product, because see, it's not only about the product, right? I was telling you about, for example, this product which I was talking about. You can see it's like a suitcase, right? Like a laptop, you can see. Now, a student, when he is traveling, now he should be able to carry like this, modular form. He should be able to put it in bag and carry wherever he want. Or like that, you might have seen some products. You are surprised to see that, for example, whatever you are purchasing online, today you are purchasing even the beds, right? That is single bed, double cot beds, or you are purchasing the furniture, dining tables, and so on, or shoe racks. You are surprised to see that when they are sending by courier, you have noticed that they are in a modular form, right? And even the bicycle, right? The exercise bicycles, what you can see is that they are available in a modular form. So the customer is able to assemble them, right? The customer at his or her place is able to assemble them. But then why this modular structure or you can say design for manufacturing is important, is because every part you might not be manufacturing, right? Every part you won't be manufacturing. You have to buy some of the parts and build the system. Like in my case, no, the cabinet part, I want to make a low cost, but at the same time modular form, lightweight, carryable. So you have to identify that, instead of that big box, wooden box, metal boxes, nobody would like to carry them. So you have to look for design for manufacturing aspects and also the transportation part. Okay, so yeah, I mean, there are two ways of doing the things: either sequential design, that means one after another, or concurrent design, that you have various teams which are working simultaneously on those products. So finally, I mean, just to conclude, I will say these are the various phases or stages of any product. One has, you have to have your own strategy to do the things. And nowadays it is also encouraged in academics. Professors or institutes are encouraged by the AICT, and now it's, there is no here any restrictions, right? You are free to do that. Yeah, that's all from my side. Yeah, I'm open for the questions.
Okay, so if there are any questions, I would request participant to unmute and ask.
So in the chat box, I'm typing my email ID. Anytime, if you require any help, you can mail me. Or
Participants, if there are any queries,
yeah,
please feel free to unmute and ask.
this is my mobile number. Anytime, maybe text me first, then we can have a discussion. Yeah, so the question is, motivation. See, my suggestion is, right, there are good number of, centers are there in India. I don't know, Deepak, from where you are. The Government of India, Department of Science and Technology, DST, is funded in various states, right? In Maharashtra, we have some centers, like in every state, there are some centers. My suggestion is definitely do two things. One is every year there are exhibitions by multinational companies. Okay. And the multinational companies, they have these stalls, right? They also encourage the engineering students to participate in their exhibitions. They fund it also. So make sure that your students, those who are interested in converting them projects into products, ask them to first attend those exhibitions. They are free. They're happy. Those stalls are happy to explain their products. They should see that. So that's one motivation factor. Second is almost every state, big cities, nowadays it has started in rural also, has these technology business incubation centers. Right? At least ask them to visit them. No, so they will have that idea that there are people who are willing to fund for their projects and products or ideas. So you should have some carrot. So it's always better motivation. If we say, probably they may ignore, but if the things which are already happening, if either you ask them to visit physically, or maybe you can invite some guest speakers from those TBIs. That's a good idea, just to know about what is this funding and the business models. Yeah, Deepak, yeah, NMIS has a TBA. So try to invite some good speakers. They will motivate or they will explain all these stages. Because teacher, if we say something, no, they still see that as a project. But the TBA fellows, the language is slightly different. Yeah.
Any other questions?
Yeah, okay, then they can mail me otherwise also.
Okay, sir. Just give me a minute. So on behalf of the Atal FDP team, I would like to thank our speaker for this session, Dr. Y.S. Rao, for conducting this session. So please accept this token of gratitude from our Atal FDP team. Thank you very much, sir.
Thank you all.